Hello everyone, welcome to our third lecture on AI for Earth observation. In the last couple of lectures, we saw a bit of the basics about Earth observation, and at the same time, we have also seen a few example use cases where Earth observation can be useful rather than deploying in situ sensors. So we'll come back again to some of these examples later today also. We'll actually keep coming back to these examples during this course from time to time. However, at this point, let us start by talking a bit about what is this course is all about. So the first point that we need to understand is that this is not an Earth observation course as such. If your goal is to study different Earth observation sensors and their underlying principles in details, there are probably other courses even on NPTEL which are more suitable for this purpose. This is not as such a computer vision course as well, even though I would say that there is good amount of overlap with what would have been otherwise a computer vision course. It's probably not so easy to quantify like how much overlap, but I would say like at least 25% overlap with what you'd call a more like a DL for CV like computer vision course. And at the same time, then the question arises that whether this is a deep learning course. So again, the answer is no, this is not a deep learning course. There are surely other courses available in NPTEL or like other platforms which are designed for deep learning, whereas this is just talking about a particular application area of deep learning. And we really don't cover, much of the theoretical aspects of deep learning. In fact, if you don't have exposure to deep learning when doing the course, you may need to actually do a bit of, like I'm not saying a lot, but a bit of self-study. Since we'll be talking about, let's say like in the week 3, we'll be talking about specific CNN architectures. However, we don't really go to introduce the convolution and related other techniques from deep learning point of view. So there, like if you don't know like what is convolution, you may need to actually consult a DL course. Whereas on the other hand, of course, like when we talk about a bit more specialized versions, our assumption is that you have some exposure to the DL or you can do that much self-study. Whereas like when we talk about a bit more specialized version, like we'll be talking about 3D version of convolution as well at some point. There we would actually talk the basics a bit more. because the assumption is that probably even if you have some exposure to another DL course, uh, probably you have not studied about the 3D convolution. So what this course is about, as I just said, that this is AI for you, or rather the more appropriate way of calling this course is probably DL for you. Why I'm saying that this deep learning for you is the more appropriate way? Because most of the techniques that we discuss in the course is in the context of like how the Earth observation algorithms evolved after incorporating DL based techniques, which in the case of the Earth observation, even though with the AlexNet from 2011 onwards, in the computer vision, deep learning was being used more and more. In the Earth observation, I would say deep learning started to be used more from 2015, 2016 onwards. Even 2015, 2016, we see very few papers which actually used DL. Maybe 2017 would be much more appropriate timeline. It's not the case that before like 2016, Earth observation was not using any kind of AI or ML. In fact, even like if we see like the late 2000s and all those times, like much before 2016, we'll see machine learning was indeed used quite a lot in Earth observation. However, those where the methodologies predating deep learning, such as support vector machine was used quite a lot. We in this course, we don't focus on those techniques as such. It's not that we don't cover at all. In the week 2, we talk about them a bit, but otherwise we don't focus on them. Our focus is rather on the starting from deep learning. So starting from CNNs to transformers. So this course would be interesting for you if you would like to learn about this application area of the deep learning. And it might be the case that you can say that, okay, I really don't work in Earth observation. Will this course be any useful for me? The answer is yes. I mean, if you're still interested, like, to apply deep learning in some other application area that may not be Earth observation, that may be, let's say, like medical image analysis, that may be something else. But even then, I would argue that the course is reasonably relevant for you. Why I'm saying this? This is because most of the techniques that will be covered in the course, they, in one form or other form, they can be used in the other application domains as well. So to summarize a bit, again, what I'm saying is that if your goal is to, like just learn Earth observation, like let's say what are the physics behind the images, different types of images and all in details, then this course will not provide you that depth. Whereas if again, like your goal is to learn deep learning techniques from, like more from theoretical aspect, again, this course will not give you that depth. Whereas if you want to understand, like, okay, how to apply, let's say, CNNs, how to apply transformers to different imaging applications, even if it's not Earth observation images that you are concerned about. This course will indeed provide you significant background that you can actually go beyond Earth observation images, and you can also apply to those. And of course, if you're interested to apply to Earth observation images of data, this of course is the course for you. So to understand this aspect a bit better, so I'm just trying to emphasize this again and again, because this is the very beginning of the course, and at this point of time, it makes sense to clarify this well, so that there is sufficient clarity for you to decide, okay, whether this is the right course for you. Or let's say at the same time in the NPTEL, some other courses are running this semester and you probably want to go for the other course. Obviously, if you are rather watching at a later time, not following the course as as you want to get a certificate or something, and then it's a different thing. Then you can of course just jump to any point in the course. Then probably this discussion is not so much relevant for you. So in our IIT Delhi, our department, the School of AI, the courses we have divided into these 4 buckets, learning bucket, which includes courses like, let's say, deep learning, machine learning, or reinforcement learning, let's say, maths bucket, which includes, let's say, courses like optimization and all. There is a data science bucket, which includes courses like, let's say, data mining, information retrieval. Then there is an application bucket. And if you ask me, where this particular course belongs in that, IIT Delhi School of AI's course bucket mapping, this belongs to the application bucket. Indeed, the counterpart of this course that is defined in IIT Delhi, though there is some difference in the syllabus, that particular course is indeed a part of the application bucket. Now, with this, also talk us a bit about the course outline. So week 1, as you are seeing, we are introducing the Earth observation. We are currently also introducing the course as it is. Now we are talking about the course outline. We will be talking about the multispectral images, the hyperspectral images, SAR images. Eventually, in the week 2, we'll also talk a bit about more traditional, and traditional need not be non-machine learning. Traditional here means okay, what was before deep learning. So our era, as we talk in this course, is basically divided into, I'll say 3 era, not 2. So one is, once we started using CNNs, RNNs and all. So this is you can say that the modern era. So traditional is before that, where still machine learning was used. Still supervised machine learning, unsupervised machine learning were used, but not as such deep learning. I mean, probably neural network was still used a bit, but not deep learning in the way that we see today. And then there is a postmodern era, which is last few years, where we see transformers, vision transformers, they have been adopted. And we eventually see that vision foundation models have been adopted, or the vision foundation models corresponding like earth observation version has been designed. So this is week 1 and 2. With this background, we will move to the week 3, where we will be mainly talking about different learning paradigms. So supervised learning, self-supervised learning. And here in this context, we'll also discuss different popular CNN architectures, like let's say AlexNet, ResNet. So all those architectures in the context of classification. Then we will move to week 4. In a way, we are still continuing our discussion on the learning paradigms here. So we will also talk about generative adversarial network in this week. Semantic segmentation. So from image classification, we are moving to semantic segmentation in this week. So you see, like, clear relation. Why I said that, okay, if you have to actually like see the overlap, probably the clear overlap is with a DL for computer vision course. Like this week 3, week 4, a lot of content overlaps, and we'll see later also, like there are other weeks also later which overlap strongly with the DL for CV course. Now the week 5, we will be taking forward our discussion to SAR image analysis. So we'll be talking in the context of, let's say, SAR classification, but also at this point we will also introduce object detection, which we have not, like, let's say, discussed before. Like till week 4, we have talked about semantic segmentation architectures, let's say UNET, but we won't be talking till week 4 like object detection architectures. In the week 5, we will be also introducing object detection architectures. Week 6 will involve discussion around hyperspectral image analysis. So again, I mean, reuse of some of the architectures which we would have discussed before. But at this time, we would also be talking about 3D CNN a bit. There are some other aspects also, like which we'll be discussing at this point, like let's say channel attention. So these are some interesting aspects which we would not have covered before, but we will be covering when we'll be discussing hyperspectral images. Due to their strong relevance, like, okay, these particular architectures, they are strongly relevant to the hyperspectral images. That's why we introduced them first time here. Week 7, we will be talking about multi-sensor differences, geographic differences. And in this context, we'll be talking about domain adaptation, domain generalization, so which are often used to mitigate this multi-sensor or geographic differences. Following this, week 8, we will be talking about change detection. In the change detection is a very important area in earth observation, and this will again involve introduction of some of the architectures which we have not have discussed before, or at least not in details, like Siamese networks. At this point, we will be talking in the context of supervised change detection. Similarly, we will be talking about, let's say, unsupervised change detection and all as well. Week 9, we'll talk about application with respect to some specific domains, like urban domain like forestry. Similarly, let's say like glacier. So some domains and like how to, let's say, build up on the top of some of the architectures which we have. Some of the architectures or some of the like the component tasks, I will say, like semantic segmentation, change detection, which we have discussed before. So following this, week 10, again we see like a strong overlap with the DL for CV course. At this point, we would be talking about vision transformers, also a bit about diffusion. Eventually, week 11, we will be taking this discussion forward to talk about vision foundation models. You would have heard names probably like segment anything model or clip or like other such vision foundation models. They will be introduced in this particular week. And here one point to understand is that what we are saying is like vision foundation models, like those which has been introduced actually in the context of computer vision, not necessarily in the context of earth observation, which rather will come later. Then, yeah, here we are coming to that week 12, where we talk about both EO-specific foundation models a bit, and also like how to adopt like the foundation models, like whichever, like even if it was proposed in the context of like computer vision, like SAM, the original SAM, for EO talks. Okay. So with this, I would like to again like emphasize this point. So in this, I have already mentioned a bit before that there can be two types of audience here, right? Like one is like who are actually like doing this particular course as it is being offered this particular semester. But then like there will be another class of audience who like at some point of time, like maybe even in future, like they just access this course and they want to get exposure to this topic. I mean, all the time that I have visited NPTEL course, I was in the second category actually. So for this second category, I mean, not necessarily time constrained. Some of them could also be just like they're accessing at a later date when the course has already like course has been offered. So however, if you are like in the time constraint audience, then you can actually even jump to specific topics. I mean, for most topics, not everywhere, for most topics, like how I thought about this is that to keep some intentional overlap. How does it help? The intentional overlap I'm talking about. Like let's say you jump directly to change detection. You have not like actually gone through the initial weeks. So due to this intentional overlap, you will not need like I mean, or at least like some of the things that you will need for the change detection are also covered quickly in the change detection lectures, let's say. So this is just an example. I mean, need not be change detection, like be some other topic, or let's say like when we are talking about hyperspectral images in the week 5 or 6. So hyperspectral images, I mean, we are introducing already in the week 1, 2, right? However, when we are talking again later, the dedicated week for hyperspectral images, we are actually again talking a bit about like the basics of the hyperspectral images. So even if you have not seen the week 1 and 2, it's not that you cannot actually do that later week at all. However, if you are actually following this as a course, of course, you should follow it sequentially. Then you should not just like do a step jump. Okay, at this point, I would also like to talk a bit about like one of the large audience in this course, as I would expect. I don't know like who all will be registering, but as I would expect is like the research oriented students. So for them, like also it's important to understand different research resources. So I have just listed some of the journals like where or conferences where I look personally. So I'm not saying these are the best journals or something, but rather this is somewhere where I look. My preference probably it would be valuable for you also. So one is IEEE TGRS, IEEE GRSL, IEEE JSTORS, conference was IGARS, which is a it happens annually, and you will get like must number of papers there, like upcoming papers. So the idea in this particular domain is most of the time is that like people generally publishes an initial version in IGARS or some other such conference, and then build up on the top of this and they try to submit to a journal. Then there are also area specific conferences like EUSAR, USAR for SAR, or WHISPERS for hyperspectral image analysis domain. And there are many other journals and conferences. So as I said, that the list that I was given was not an exhaustive list. So there are many other journals and conferences, like those from ISPRS are also very well known. And I also refer to them from time to time. Talking a bit about remote sensing acquisition platforms, two things we need to understand, which is very important here, is that revisit time, that is the time between the successive observations, and the spatial resolution of the remote sensing data. These two are like very important aspects, and they are determined by the specific acquisition platform that we are talking about. And in this context, we can have geostationary satellites, which provide continuous monitoring of the same area. However, typically with spatial resolutions ranging like around few hundred meters, so you see like it's quite coarse resolution, right? We can have polar orbiting satellites which revisit locations every few days or like few weeks, and they can achieve high spatial resolution. So most of the time when we talk about like particular satellite sensors, we actually talk about this polar orbiting satellites. And as you would have guessed, like if you have like one particular polar satellite, and I'm saying that okay, it can revisit in a particular number of days, so you can use more number of them, okay, and you can have a better coverage. So more non-technical example here is that like let's say your friend is unwell and admitted in the hospital, and you have in a group of friends, all of you have your own personal lifetime commitments, right? So what would happen is that if you were actually visiting yourself, you probably could have gone like once in 3 days, but what you could do is that you could timeshare with your friends, and thereby you could get a better time coverage. Also, in addition to these acquisition platforms that we just talked about, we also have the aircraft and UAVs or drones, which enable on-demand data acquisition. So let's say like an earthquake has happened, it makes sense, like if of course the budget permits, and the budget permits on like okay, which location we are talking about, how rich is the municipality or the local government. And if the budget permits, it makes sense that okay, we don't really wait for some air, like some satellite based, especially we are talking about here like the satellites, not geostationary satellite, rather the satellites like where it will be coming back in a few days. And we cannot really wait for that, right? Rather, we'll be deploying, let's say, drones, or we'll be doing an aircraft mission. Here, aircraft missions are generally more expensive, whereas most of the time the UAVs will provide, compared to a like aircraft mission, will provide a lower cost alternative. There are pros and cons, and both can deliver a very high spatial resolution images. Again, depends on like which particular like camera and all has been used, sensor has been used, but still like compared to the, when we're talking in comparison to the satellite based platforms, which are much further away from the aircrafts and the drones in the sky layer, right? So the aircrafts and drones, they provide generally much higher spatial resolution images. Okay, with this, I will stop here and we'll continue our discussion in the next lecture. Thank you.